Hello all! Today I'm going to be going over real/irrational proofs. First, let's jump into the definition. Our definition is a real number is called rational if r equals a over b for some ab integer with b not equaling 0. The first problem we have is let b and u. Now, this is our hypothesis that we are going to assume to be true. So first, let's start out our proofs like we usually do. Okay. We are going to assume our hypothesis to be true. So we're going to assume that u and v are rational. Then, by definition, I can never spell definition, so hopefully I spelled it right, of rational numbers, we have u equaling a over b for some a b, and very important, b does not equal 0. Now, where did I get that information? It's easy, straight from our definition. But we also assumed that v is rational. So we're going to say and v equals, instead of using the same variables, I'm just going to use c and d. You could put that as like a sub 1, but things would get complicated. So let's just do c and d for some c and d integer with d not equaling 0. Now let's check. U times v is equal to, well, we have set u and v, so let's just plug them in. A b times c d. Now multiplying them out, it's just going to be ac over bd. Now a an integer times c an integer is still going to be an integer, which is still in our form. So it checks out. So all we have to do is what I usually do is have it equal this. This part can kind of be superfluous, but just so I cover all my bases, I usually do it with m equaling ac, which is an integer, and n equaling bd, which is an integer, and n also does not equal 0. Now we can double check this. B we've already defined as not equaling 0. D is not equaling 0, so there's no way them multiplied by each other is going to be 0. And that is by the 0 product property. Now, just write your conclusion. Thus, u times v is perfect. Now going on to problem 2. So, this I couldn't prove. Instead, I'm going to prove it using the contrapositive. The contrapositive is as follows. So this right now is in P implies Q. The contrapositive is not Q implies not P. So let's write it in contrapositive form. So instead, we're going to have if, because we need those qualifiers, the if and then. If u is rational, then 2 over 5u minus 3 over 7 is rational. Now this looks a lot like something we can prove. Based on either prior knowledge or the knowledge you just learned, see if you could write this one out. I'm going to go ahead and start with proof by contrapositive. So we're going to let okay. So then, by definition of rational numbers, u equals a over b for some a, b, integer with b not equaling 0. That's the part that we're comfy with, we're familiar with. Now, let's apply it here. Then, 2 over 5u minus 3 over 7. We know u. We define u. So let's replace it. So 2 over 5 minus multiplied by a over b now is minus 3 over 7. And if we were to just use our basic fraction knowledge, it is going to be 2a minus 3 times 5 over 5b times 7. If we simplify this, we get 2a minus 15 over 35b. Now I'm going to do what I did earlier and have this equal m over n, with m equaling 2a minus 15 for some a integer, and we're going to have n equal 35b for some b integer with b not equaling 0. Now all we have to do is write our conclusion. Oh, and you can also say that this is by the ZPP or zero product property. Finishing this off, thus, now it's important that we say that we did this by contrapositive as well. So we're going to say 3, 5u minus 3 over 7 is rational by contrapositive. Is that what you got? I hope so, or hopefully I didn't make any mistakes. Well, thank you so much for mathing with me today. If you have any questions, please leave them in the comments below, and I will try to answer them. Thank you.